Okay, so let's start off with the Maytag washer and the questions for the Maytag washer. That was the two separate pages where you had the diagram and the timer chart on a separate page, and these 9 questions. Number 1, does this washer have a bypass switch?
Yes.
It does. Let's go look at the timer chart. This is a timer chart. Is there something here that says bypass switch?
Yes. Number 6.
Nope.
6.
6 tops.
6 tops in and timer motor bypass. Okay, so we went over the Whirlpool direct drive the other day. We went over an Admiral washer and we pointed out bypass. Most of these washers, I said before, have bypass switches. What does the bypass switch bypass? What component, or why do we call it a bypass switch? Not the timer. It doesn't bypass the timer. It bypasses the water level switch. So if we look over here at 6T, and we're looking at 6T, so if you look at all these numbers here that are circled, those are all switches inside of the timer. And the switches inside of the timer, they have switch numbers and they have cams. So these numbers here, 8, 12, 10, 6, 4, 2. Why did that just close on me? The whole file just completely closed. 1 second. Sorry, I don't know why that happened. Let me reopen it. I love technology. Yes, reopen what I did. So going back to here, we said it was cam 6T, which means the top of that cam. So if we look here, 6T is right here, from here to here. And what is it bypassing? It's bypassing the water level switch. And why is it bypassing the water level switch? Because when the machine wants to drain and spin, normally the water level switch sends power to the motor here and our timer motor here when the machine's full of water. So if I just want to just say the timer motor, and I'm not going to do the drive motor yet, I say the timer motor here, right now, technically the timer motor's sitting here waiting for this water level switch to go into the full position. So when the washing machine's first turned on, and I think we said it on the other diagrams, when the washing machine first turned on, it fills with water. We don't want the motor to run while it's filling because it's going to damage clothes. We don't want the timer to advance while it's filling because it's going to take away from our wash time. And if you have poor water pressure in someone's house, it could take forever to fill with water, and then we would lose all that wash time. So instead of the timer waiting for this during the spin cycle, the timer would come here through this bypass switch, and it does. I know it's a long run. It runs up to the lid switch, doesn't go through the lid switch, it just comes right back to the neutral, and then it jumps right here. It doesn't go through the water level switch, but it creates a neutral circuit both for the timer motor and the drive motor, okay? And you'll find that on almost all mechanically controlled washing machines. Not the computer-driven ones, because now the computer doesn't totally rely on the water level switch to supply power to the motor. And the computer itself is already getting power, which is really what? What is the computer in an electronic controlled machine? It's taking the place of what inside of a mechanic machine? The timer. The computer is just an electronic version of the timer, okay? So we'll get into electronic machines, but I felt that this is very important. And I have next week some more stuff for you guys to do, the next level, a little bit more troubleshooting. I want you to be used to looking at these diagrams and circuits. Yes, sir.
Are these timer little units being phased out, or are they still making it for like the lower end? Stuff like that?
Still the lower end, still have some mechanical timers, but everything's eventually going to go to electronic. One of the reasons is look at all of these wires on all these different here, like gentle spin, gentle wash, super wash. All three of those switches are mechanical switches that run from the motor to that switch and then back to the timer. So you got wires that are coming from the motor going to these extra switches and then going back to the timer. I could just create a computer board and say slow spin by pressing a touch screen, and that control board is going to make it low spin. I don't need to add additional wires going back and forth to the machine. So not only does the electronic board take away the place of a mechanical timer because the timer's, cumbersome and everything else, but it also reduces the amount of wiring that's inside of a machine. When we look at a computer board, it's just a box like this, and the motor's over here, and we got a couple of wires running to it. That's it. We got a lid switch, a couple of wires to lid switch. We got a water valve here, and just got wires running there. We've reduced the amount of wires. We've reduced everything else. But, these mechanical machines have been made for 40, 50 years, maybe longer. I don't know when they first started making these mechanical timer switches, but they'll probably be around another 20, 30 years until eventually they all just die or parts are no longer available because manufacturers are only required to actually make parts available for so many years after they produce a product. So if a timer fails on a real old machine, even though the machine itself may be good, you might have to dispose of it anyways because the timer may not be available. Remember that one dryer you've been trying to get that timer for, it took forever. So anyways, that's that, and that's the bypass switch number 1. So let's go to question number 2. If it does, what cam would it be? And we basically said it was cam number 6. Can someone tell me what the switch numbers would be? In this case, it's not a single number, but if we were trying to identify it, you could either see it on the diagram or you could see it on the chart. If we go to the chart here and we go to 6T, well, that's the cam. That's cam number 6 and the top of the cam. Okay? But what is the switch number?
16 to 7N.
16 to 7N. And I'm assuming the N might stand for neutral. So if we look here on the diagram, can you see the 16 and the 7N is also printed on the diagram?
Yeah.
Okay, so like I said, these assignments that I'm giving you, the main purpose of these assignments are not to troubleshoot a machine. This is just pointing out little bits of detail and make you understand what all this information is on these diagrams. So now when I start asking you more technical questions, you're at least familiar with a lot of the information that's already provided to you in these diagrams. Okay? So number 3, what cams control the direction of the washer? 2 and 4, very good. It's cam number 2 and cam number 4. They control what? What do those cams control? I know they control direction, but what do they directly control?
Spin and agitate.
Look at the diagram. I'm looking more for something within the diagram. What are they actually sending power to?
To the start?
To the start winding inside the motor. Because and the reason why I'm bringing this up and pointing it out is because there is something I'm going to talk about these motors, because a lot of you, when you look at these motors and all these wires, it's a little bit complicated. Now, all of you, when you started, there was a chapter on motors where you had to bench test these reversible motors and test them out and everything. And I actually used this diagram in that PowerPoint that you guys sat down with the motor and tested the motor and made it go one way and then reversed it, made it go the other way. This is the actual diagram in your PowerPoint for Atlantis motors. Okay? So yes, you can see you were also correct that those two, cam 2 and cam number 4, see it says reversing agitate, reversing spin. Well, it can't reverse twice. So it just reverses the motor for one way and then it reverses it back the other way. That's what they mean. One thing that's important though is if one of the agitates are energized, the other agitate has to be energized. That we have one switch before the start winding and one switch after the start winding. And on these reversible motors, we need two switches, one before and after, that send power through the motor. So we got, if you look, it says here, reversing spin, reversing spin, reversing agitate, reversing agitate. If you look at this pattern here, notice how when this reverse agitate is highlighted, this reverse agitate is highlighted. And we got a 2-position gap where now it's in spin. Well, now we got 2-position gap where this one's in spin. Then they're both in agitate for the same amount of time. They're both in spin, both in agitate, both in spin, both in agitate. And if you look, the patterns are almost identical but opposite because of the way they drew it. But in these washing machines, those patterns are the same on all these machines. All these machines have 2 switches before the start winding, 2 switches after, and we close one here and one here for spin, and then we close the other 2 for agitate. Okay? Well, guys got any questions? Yell out, hey. Number 4, how many cams does this washer have?
15, right?
12? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know why you said 15 because you saw the 14 and then you said 0. You got to add it. But look, we don't have a 5.
Yeah.
We don't have a 7.
Right.
We don't have an 11. So we're missing those 3. And that's why I know what you did, but you didn't take the time to count them.
Yeah.
Okay? All right. So even on my answer key, I wrote the wrong number down because I didn't count it either. I just said 14. So the answer was 12. Very good. But see, you guys are looking now because if you just looked at it at a glance, you wouldn't realize it was missing 3 numbers.
That's right.
Okay? So each one of these questions, again, is to get you to focus on just a portion of that diagram to learn what that one portion does, not the whole diagram. We build it all together once we break it down into bite-sized pieces, okay? How much time is each increment in the washer?
187.
180 seconds. Was it on here? Oh, you're right here. I was thinking the other diagram, the Frigidaire, and it's not right there. 180 seconds. Very good. What increment does the basic White's cycle begin and end at? So what increment number does the basic wash cycle? So here's the White cycle here. This is part of the White cycle, but that's not like the basic. That's like an extra addition. So it starts right here. And that's actually number 7. If we look here, watch. 1, 2, 3, 4, 5, 6, 7. It starts on the 7th increment. Well, even if you say because it's in the middle, if that was 5, then 1 would be here after the first space, not before the first space. You could call it 0, but I don't have a 0, so I'm going to assume each box, because the box is the actual increment, not the line. Okay? So that's 7, and what increment does it stop at? What? 21. Well, let's see. If we keep going here, we look for the off position, which is right here. So I go all the way over here, and this line here is 20. So this is 20. This is 21. That'll be 22. So the answer there is 7 and 22. Now, it could have an extra rinse at the end and make the cycle longer, like we added an extra wash at the beginning, but I asked for the basic, the minimum portion of that cycle, okay? What switches are closed in increment 7? Well, increment 7 was here.
That's 17.
Oh, 17. Very good. Sorry. I only have one contact lens in. I don't have the other. I keep walking around the circles. So if we go 17, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I'm going to go ahead and highlight that there. So those are the switches that are closed in increment number 17. Now the question was, how many, so which one were it? What switches are closed? So now, if you told me the very first switch that is closed, what is the very first switch that is closed?
L1 and 44.
Very good, because I was looking for the switch numbers, not the cams. So those of you who put the numbers should have put L1 to 44. What's the next one?
21 to 31.
Yeah, this one's not being used, even though it's highlighted. That might be the push-pull switch on the timer, by the way. Okay, we'll take a look at that in a second on the diagram. Now, the next one is 21 to 30, right? 21, 30. The next one?
L1 to XR.
L1 to XR. Next,
22 to 9.
22 to 9. Okay, 1630. And the last one, which is XR to 11. So we take this and we follow it over, but that is the numbers or the switch number. Okay, they call it the circuit. It's basically the switch. Okay, that distinguishes it from the top and the bottom of the cam as well. All right. What is the cycle and machine function in increment set 17?
Field and race.
Okay, so the cycle is whites. The machine function is it's going to fill, and once it fills, it's going to agitate. Agitate doesn't mean wash. Agitate just means it goes back and forth and agitates the clothes. The difference between wash and rinse, which is agitate, is what? What's the difference between wash and rinse? What?
One goes the whole.
No. If you wash your car or you rinse your car, what's the difference? You use soap to wash, and then you just use plain water to rinse. And that's what we're talking about here when we say wash or rinse. It's the same thing. It's still, the motor's still washing or agitating, but it has soap in it or it don't have soap in it. That's the difference between wash and rinse. Okay? Close the switches and highlight the circuit for number 17. So someone knows all those numbers, so when I go to the next screen, you can tell them all to me? Okay, so let's go back here. And what are the switches that are closed? L1 to 44, and that is right here. And this is the push-pull switch, so that isn't that one that I pointed out said maybe push-pull. That is the one that the customer pulls out and starts the machine after they rotate the dial. What's the next one?
21 to 30.
And what cam is it on to help me find the location of it?
Number 2.
Cam, okay, 21 to 30. So that would be this one right here. So if you could see the 30 is there, that one's 30, but that is also 30, and 21 is here. Okay. What's the next one?
L1 to XR.
L1 to XR, the cam?
3.
Cam what?
3.
3. So this is L1 to XR here. The next one? 22, 29, cam 4. And that's this one down here. Now you could see the switch numbers are there, but it's easier to find the switch if you go by the cams, right? Some manufacturers don't put the cams on the diagram. They only have switch numbers, like the Whirlpool one that we did the other day. What's the next one?
16 to 30, man.
Okay, 16 to 13
30.
on cam 6. So cam 6 is here, 16 to 30 is right here. And that was it, right?
One more. There's cam 13. XR to 11.
XR to 11 is right here. This is XR running down and running in the middle, and 11 is there. So because I didn't specify that the water level switch was in the fill or the wash cycle, okay, I expected you to go by the position that these switches are in this circuit. And one thing with this is that even though there are switches like for this motor that are closed right now, they are not energized. They are waiting for the water to come in. Okay, so when power comes in, yes, I could have followed this down. It does go through here. That switch is open right now, which means the lid's open, but we come here and it supplies power into this board. This board is, it says the water and signal control. Signal is like a buzzer, like the washing machine actually had a signal like a dryer to tell you when the cycle was done. The customer had the option to disable it. That's what that signal switch is for. And the water controls like faucet switch. Sometimes customers weren't happy with enough water that went in the machine, so they would press that button and it would allow more water to come into the machine. So that's what that faucet switch was. But the reason why they had this board, if you look here, we already have a temperature switch. So you're like, well, if I got a temperature switch, why do I have a board before my water valves? Because this machine, remember we talked about the other day, if the water was too cold or it was too hot, it would cause a problem with washability. So that we had to either take water that could be 35-degree water and make it warm enough so the powder detergent would dissolve, or water that may come in at 110, 120 degrees. We want to make it a little bit colder because that excess heat would cause the colors to bleed out of our clothes. So that board is controlling the water temperature up and above what the customer selects. So if the customer selects warm, you're going to have 75, 80 degree water. If it's cold, you might have a 60 to 70 degree water. And if it's hot, it may be only 100, 110 degrees, but not too hot or not too cold. I had one customer had a Frigidaire laundry center, like the next diagram we're going to go over, and she lives in an apartment complex. Something went wrong with her original washer, and when they gave her the new one, she was complaining because she put it on cold water, and she put her hand there and says, "This is not cold water. This is warm. I chose cold." Well, I tried to explain to her the theory and function of that water temperature device. She says, "I don't care. I want my old one." I ain't gonna tell you what I did on camera. I'll tell you later what I did. But the apartment complex didn't care, and she was happy, so I did it. So anyways, that's one circuit, but that's not the complete circuit. The other line is coming up here. We can go through the extra rinse, but that's open. So we're gonna go through here. We're gonna jump here. We're gonna follow this through this switch, and we're going to feed our temperature switch. Now look at that temperature switch. Now I talked to, I think it was you, Ricardo, about it, but don't answer it. Let me ask them that. Looking at that, how many contacts are inside of that switch?
The water temperature switch.
The water temperature switch, yes.
6. No, don't say 5, but it is like
How many? Well, there's 3 switches, right? There's 3 individual switches inside of there. What is the position that switch is in now? Hot, cold, 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 warm, cold, warm, warm.
warm, cold.
Well, how do you know?
It's repeated.
Well, if you look at this first switch, if it's in warm, warm, it's over to the right. If it's in hot, cold, warm, cold, or cold, cold, it'd be over to the left. So if you see, I got warm here, so it's closed this way, and I have warm there, it's closed that way. If I chose a different temperature, let's say I chose hot, cold. Looking at the three switches, what switches are closed in the hot, cold?
The first one and the last one.
Well, the first one's open if I chose hot, cold, because the HC is to the left. Hot, cold is on the right, so this one would be closed, and hot, cold is on the left. So the only switch that would be closed if I chose hot, cold is the center one. If you look at it. Because that's the only one that has hot, cold where there's wires connected to it. The hot, cold here and the hot, cold there have no wires to it. Those switches are technically open. Okay? Do you guys understand that, or do you want me to do one more?
One more, why not?
Okay, cold, cold. Which switches are closed if I chose cold, cold?
The one to the right.
Just look at each one. This one's going to be open, this one's going to be open, and the one on the right is the only one that's going to be cold. So do you understand what all those letters and numbers mean now? Again, this is what this practice is all about. Okay? A lot of people look and say, well, how do I know what temperature that switch is at? It's there. It tells you. But you didn't know how to read it. Okay? Does that make sense? Okay, good. So let me just erase those lines because we're going to go through that switch there. And I come in, I come down, and I'm going to feed warm rinse. So we got the warm rinse there. This is hot and cold, but we got nothing coming in on that line, do we?
For the cold rinse? It should, because doesn't it jump off at the left and the right?
But we come here, like you said, and we come in, and we're feeding the board there. Up here, down, and into the board there where it says cold rinse. Okay, so you see that circuit, right? So there are other circuits in here. If I follow this line over and come here, it jumps over and goes into the board there. That's feeding line 1 to the board. That board has power all of the time. It's not just for fill. Remember, it also controls the signal at the end of the cycle. Now, if the customer closed the extra rinse or whatever that temperature control switch there, like this, then this would be 2. Temperature control switch off. What does that mean?
Is that time drive?
This is a washer. Time drive. What that is, remember I told you we have this board controlling temperature. If that customer had this washer, they could actually hit that switch and it would give you direct hot and direct cold, and the control board wouldn't control the water temperature. It would just be the water valve is on or off. No matter what that board says, that board will not try to control the temperature of the water. Okay? So if we have this switch closed, I'm assuming that means that the board is off. And if I chose warm, warm, I'm going to get warm, warm in both circuits. Okay? So now that I've fed power to my board and everything that's going to have power there, we do have our water valves here. And since we chose warm, warm, what valves do we need to energize? Both of them. So I'm going to come off here where it says cold and hot, and I'm going to bring cold in, and I'm going to feed the cold water valve, and I'm going to come here and feed the hot water valve, and then I'm going to come through here to the water level switch and go right out here to neutral, which is the end of the power cord. Now there's one last thing that needs to be energized. Does anybody know what I did not energize? There's only one small thing in that circuit that's not energized. No, the motor's not running. Even though these switches are closed, that motor's waiting for that water level switch to go to the full position. Remember, it doesn't run while it's filling.
Timer motor?
No, because the timer motor and the motor are waiting for the water level switch. Remember, we said While it's filling, those two are not going to run.
Yeah.
But if we look at this here, what is this piece right there where that little dot is that I put? Starts with a T, guys. You all hear me say that word all the time. Yes, say it, Douglas. Thermistor. That is how the board knows if the water's too cold or too hot, and then it'll add more heat or more cold depending on what temperature we're trying to get. Okay, that's what your diagram should look like. Any questions? That's okay. It's good that you make mistakes, because then if you see what the difference is, you say, oh, wait a minute, it's got to be this. Any questions on what we went over so far before I go to the next diagram? We also have the video.
If you look at the timer sheet again.
The timer chart?
Yeah, it does say on cam number 8.
Cam 8?
Timer multiply class, so it's still the same switch.
But I'm not understanding, though. What's the question?
So the question is, we said the bypass was 6T, but it also shows the same switches.
You're correct. There's two bypass switches. I did have it written down there. Yeah, I had both cams written there as far as the bypass switches. You see, I had 6T and 8T on my answer key, so I did write them both down. I didn't even look for the word bypass. I looked at the diagram and said, how would this timer motor get power if that switch is not closed? And I said, oh, well, if it comes up here and goes through here, then it could just foul this around the neutral. But then I said, wait a minute, it could also go through this one and feed through neutral. So these two are both timer bypasses. Okay, so this one had two versions of bypass. And to me, that's overkill. You know, what happens is it's the same motor, the same water valves, but the manufacturer, the more options they put on the machine, the more money they can charge. So they make the basic washer, and the basic washer has the same motor, the same timer, the same water valve, but they said, hey, you know, if we put this, you'll hear sometimes say ATC, automatic temperature control, where the washing machine has a board and a thermistor that senses the water temperature. You might hear ATC sometimes, and that's an additional feature. Well, we got automatic temperature control now, you know, and we got an extra rinse and an extra wash, and by adding a single switch, they can charge another $50 or $100 more for the same machine by adding one or two more things on there. And I can tell you, a majority of people that buy those machines that have all the bells and whistles still only use one or maybe two whole cycles out of all those bells and whistles. So if someone really wants to be frugal, don't buy the most expensive machine. Look for one that has the features you think you will use. And you're like, well, I never used this machine. I don't know. Well, how did you use your other machine? You had this machine 15, 20 years. How many times did you use more than the normal cycle? How many times did you use the permanent press? How many times did you use the delicate cycle? Well, I never used a delicate cycle. I might have used permanent press once or twice. So why do you need a machine with 5 cycles? Now, if you knew what they all did and how they could benefit you, maybe you would. But most people don't even have the time to try to figure it out. They're just like, throw the clothes in, throw the soap in, hit start and walk away, and then I'll be back in 30 minutes to throw it in the dryer. So if customers ask you, what machine should I get? You know what my answer is? Oh, ma'am, people don't invite me in the house to look at their machines that are working. They only call me to a house with broken machines. So I can tell you what machines break. Well, what machines break? Every brand has broken machines. There's some more than others, but sometimes it's only one model. They may have 5 different washing machine models, Maytag, for example, Whirlpool, and only one of those have this specific problem. So I can't tell you what the best machine to buy. I don't use all of them. I fix them when they break. They will all work good when I'm done. Buy one that I just fixed. But I don't like to tell customers to buy anything because you end up making a recommendation and that is the worst machine they ever bought, and then they look at you negatively. You tell them, I'm sorry, I'm not a salesman. I cannot tell you which one's the best one. All I can tell you is that if it breaks, I'll be here to fix it. That's all I can tell you. Okay? So let's move on to Frigidaire. Now, this was part of a laundry center. I didn't go over, I was going to ask some questions on the dryer diagram, but I didn't want to add dryers into it right now. I want to just stick with washing machines. And this Frigidaire was the washing machine version. Now, I don't know if I have questions for the Frigidaire one. Let me see. Oh, yes, I do, right here. So, does this washer have a bypass switch? If we go to the chart, does it say bypass switch anywhere on the chart?
No.
I see water temp, spray, wash fill, rinse fill, spin motor, spin direction, agitate, spin, spin path, agitate path, and pump. I'll give this to you when I'm done. So there's nothing there that says bypass, but what did I say earlier? I said they all got a bypass. Okay? The thing is we just have to figure out what it is. It's not that important that hey, this switch is the bypass switch. One of the biggest problems with the bypass switch, and I've only seen it 3 or 4 times in 40 years, as far as like that switch fail. And it wasn't that the switch, I saw it once, I think the switch failed in what we call the open position, where it wouldn't close. Well, if we look at some of the other machines, like the Whirlpool one, that switch goes through the lid switch and is for the motor for spinning. And so the customer could complain it's not draining and spinning if that switch was bad. But what would happen if that switch failed in the closed position? In other words, the switch failed to open. What do you think would happen? What would the customer complaint be if the bypass switch did not open when it's supposed to?
The water level.
They would say it wouldn't drain.
Well, the water level would still control the water. It would still drain. It would still drain. The actual problem would be is while it's filling, the agitator's agitating at the same time. And the water level switch, if we went back to the other diagram just for a minute, no, this way. The water level switch here right now is only sending power to the water valve. So when the water level switch goes there, the water will still stop, regardless of what the bypass switches are doing. But let me just clear this for a second. If the water level switch is down here, so the water valves can get power, the neutral, and the bypass switch is closed here, well then that bypass switch would probably go to the motor, and the motor is waiting for the water level switch to go up here, but if it don't go up here and we got the bypass closed, well now the motor has neutral also. So while it's filling, it'll agitate while it's filling. So as soon as the customer turns it on, you see it going joom, 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 while water's coming in. Now, what would happen is it could damage clothes, but while it's agitated, water will come in and it will agitate like normal, and it'll do everything else like normal. It'll spin, it'll drain, and everything else. The problem would be the customer saying, it's doing this and it don't have water in there. The water just came in. It's destroying my clothes. Now here's another thing, and this is more mechanical. I think I've seen it on the Whirlpool direct drive washer, the one you just worked on, the direct drive. The washer, while it's spinning, the agitator cannot be like locked in a single position. The agitator has to be in what we call neutral. Like your car's in neutral. When your car's in neutral, I can push the car, but it's not going to drive forward on its own. But what I have seen, it's not electrical, it's mechanical. When it goes from wash to spin, it's supposed to disengage something and engage something else to go from wash to spin. And I've seen it while it's in the spin cycle, the agitator's going back and forth. What do you think would happen if it's spinning and agitating at the same time? It'll tear clothes up, but what it'll also do is it'll wrap the clothes around the agitator instead of them sticking to the outside, because when it first starts to spin, it's got to get up to speed. So the clothes are like sitting down on the bottom of the basket and sitting on the agitator. So now the agitator is doing this, and then it slowly starts picking up speed. So what's it doing? It's taking your jeans and your towels and wrapping them around the agitator. So when the customer's done with the cycle, their clothes are all wrapped around the agitator. And that to me is a sign of agitating and spinning at the same time. And on most of these machines, that's mechanical, not electrical. Okay? So bypass switch is it's agitating while filling. Mechanical is it's agitating while spinning. Okay? Let's go back to our Frigidaire diagram. Oh, I'm going the wrong way. So the bypass switch happens to be number 12. How do I know that? If we go to the timer chart, we have something called spin path. The spin path is what completes the circuit for the motor and the timer during the draining cycle and the spin cycle. Okay, we'll do the highlighting of the circuits in a minute. I just want to point it out to you. So that is your bypass switch. I'll show you when we do the circuit how it bypasses that switch, okay? The next question, if so, what cam would it be? And that was 12T. How much time is each increment? I gave you the answer. It's right here. It's 120 seconds. This is one increment. This is another increment. What they're showing you here is like this one increment is closed across two, this one switch is closed across two increments from here to here, okay? And they're showing you that this one's closed, but then it's open for 10 plus or minus 4 seconds before it closes again. A lot of times that switch, like it says, motor and pump pause, when the motor wants to reverse from spin to agitate or agitate to spin, that they're going to pause the motor, almost like your car. You want to drive forward, you have to stop the car completely before you can put it in reverse. You going forward and you throw it in reverse, you're just going to tear up the transmission. Well, the washing machine the same way. If we're going to wash and go into the spin cycle, we have to stop the machine completely and allow the machine to physically stop spinning or stop agitating before we can reverse the direction of the motor. So that's what that is. Next question. Temperature selector switch, cold, cold is selected. What contacts are closed? Let's go to the diagram. And we look at the temperature switch here. That was pretty cool. Guess what? It's cut off. It's right here on the diagram. So if I go to, I had Adobe open. Give me 1 second. I had it open in the background, but when I, let me just find Adobe here 1 second. So if we look here at the temperature selector switch, these are the selections that the customer has. And if we looked at the cold, anywhere there's an X means that that switch is closed. That's what information here. So the only switch that closed is FF to C. Okay? So if we go to the diagram here and we look at FF to C, that would be this switch down here. So these two would be open. Okay? So now you know how to read the temperature selector chart. Any questions on that one? No? Y'all getting good at these diagrams, right? Or you're just really screwing up and not going to tell me and say, I got it. All right. In this diagram, cam 14 is closed. Circle the two terminals in the picture using the timer male plug where you would put your meter leads to test this switch. So let's go first to the timer chart. And it said what? 14, right? Why? I was trying to rotate it. It wasn't rotating. So in the diagram, cam 14 is closed. But here's the question. Cam 14 has two switches. Which one of the switches is the one that is closed?
Is it a T22?
No, but how do you know whether it's? I said cam 14. I'm telling you, cam 14 is closed in this cycle, right? But I didn't tell you what cycle it was. I just said in this cycle, cam 14 is closed. Well, cam 14 has two switches. Well, what cycle are you in? Are you in the agitate cycle or is the pump running? Well, that information, we got to go back to the full chart. We go back to the, why is it, let me zoom out. It's not working on the touch screen. Look right here. Look at these notes. Y'all probably didn't even read these notes, but this is the reason why I asked that question. Because this note says what? Washer timer shown in, what the heck? Washer timer shown in on position, temperature selector switch at hot wash, cold rinse, and the pressure switch at full. So they're telling you that they're in a cycle already. And that's what cycle I'm talking about. Then we got to go back to 14. Now, if I go to switch cam 14, I'm thinking I'm in the other screen. If I went to 14 top and bottom here, okay, which one is it? So I go back to this diagram here. Where's cam 14? This touchscreen is really not working for me. Cam 14. Well, what switch numbers make up cam 14? We got to go here. I don't see 14 here, right? So I got to go up. I got 4, 12, 8, 6. There's cam 14. So this is in this position right now. So one side is T22, but I can't just say T22 because it's only one side of the switch. What's the other side of the switch?
T19.
If we look here, it says T22. We follow this other line down and keep going down. That comes to here. I still don't have a number, do I? I got 22 and 24, but I don't have this number right here. So if we look here, this is the plug that's actually on the timer. We at least know it's T22, right? We didn't know the other number. As a matter of fact, there is no other number. If we look at here, T22 is here. Well, we got top, middle, bottom, or top, middle, bottom. But when we check a switch, we always check the middle one to one or the middle one to the other. So if it's 22, it's this one to 22. Well, what number is that one? I don't even give you a number. Why are they drawing this line between these three pins?
Same number.
It's an internal connection in the timer. They may not have three separate wires going there. They may only have one wire going here, but that wire is also touching these two and feeding these other cams here. Internal. So that one pin actually has three pins. Now, if we look at the diagram, I'm going to show you those three pins. Let's go back to the other screen. No, not that one. If we look here, this is one pin here. Another one is the timer motor, and another one goes there. So the three are 1, 2, and 3. That dot, and that dot. This line is called an internal conductor. So if you actually look inside the timer and you actually look at the pin, you'll see a piece of metal connecting to the two other pins right next to each other, showing it as a single pin. The only wire going to it is the timer motor. There's no wire here. There's no wire there. You see that? Any questions? Because I see a lot of people just staring at it. Okay, we got this dot here is 1. This dot here where the timer motor is 2. And this dot for the other switch is the third one. So it's this one to pin 22, this one to timer motor, and this one would be going to pin T19. So if we go back to here, there's 22, here's the 19, and that one there is probably the timer motor. It could be this one or that one. How do I know which one? We go by top or bottom of the cam. If you look at the chart, let's go back to the diagram for the chart for a second. If we look, that 22, I think was top of cam. I don't remember now. But if we go for the timer motor, right? Where's timer here? Nothing says timer. So if we go to the unit though, we got 19. They're not showing you the numbers here, so I'm trying to figure out how to correlate it so you guys can see it. And it's going to be hard to explain it to you without the chart. So I'm not going to be able to do it that way. But that is cam 12. That's cam 14. This wire way up here is part of this switch all the way down there. That's the wire that's coming in on pin 19 that's feeding that switch. And then these others are feeding the timer motor and coming out. So that one wire here is actually right there when that switch is closed. That one wire here is going into the timer motor when cam 12 is closed like that. It looks like a long run, but in reality, all those pins are right there on the timer. You just have to know that if I'm looking at a diagram and I see 14T or 12T, this is top and this is bottom. They drew the timer that way, okay? So 12T is from here to here. But you're like, okay, well, how do I check 12T? Where would you go to check 12T? You'd have to find this terminal here, which don't even have a number, and that was the one I showed you all three of them. And then the other side of that would be this one, that'd be 19. So if I wanted to check 12T, see 12T is this one right here. There's no numbers there. Frigidaire didn't put it. So you have to take the cam and carry it over to the switch and then the physical location. Then when we look at the timer, 12T was 19 here, and the one without a number were these three. So I'm going to touch that pin and that pin That's where I physically touched the timer to test that switch, 12T, right here. Bam, bam. Now, you guys know that part of next week questions is I'm going to like give you this and tell you, okay, 12T or 10B, which pins make that switch. So I want you to take some time and try to correlate those two together. Okay? Any questions on that? I know it's a little complicated. It's a little hard for me to explain it that way. It's just something you got to practice where you understand it. But every manufacturer does it differently. So this is why we're going through many different brand machines. Next week, I'm going to add GE into the mix. And we're going to look at the GE washing machine diagram now and compare how GE does it. Okay? So let's go back to the chart. The next question was, what cams are closed in increment 9? So if I went here, increment 9 is very easy to find compared to the other chart. It wasn't as easy, the other chart, to figure out which one was what number. But then we go here, cam 0 bottom, 4 bottom, 6 top, 8 bottom, 12 top, and 14 bottom. We're in the spin cycle. Look, it says spin, spin, spin. The pump's running while we're draining, right? So this is telling you what the machine's doing over here. It don't have all that information like the other charts have. The machine functions are here. Same information, just another way. So, you know, remember, a lot of these manufacturers are not all made in America. You got Korean-made machine, Chinese-made machine, machines made in Germany and Netherlands, and even them, they make them in other countries. So sometimes the engineers are not American or don't speak English, or at least their first language. So they write all their technical information in their native language, and somebody who speaks both languages has to translate it. And I'm sure those of you that are multilingual know a word in a different language that one person may say it's this and another person may say it's that. It's so vague, it has multiple meanings. So it's the same reason why we're doing so many different diagrams, because they are made from different manufacturers. They are made from different countries. So you'll find a lot of differences, but you'll also find similarities. Okay? Mark on the timer where increment 9 should be approximately in the cycle below. So if you looked at it, this says degrees. So that's temperature, right? No, it's degrees like 180 degrees or 20 degrees, like a rotation. Okay? So if we look at a timer dial here, increment 9 is here. All right? So that is about 65 degrees. Well, this is breaking in 4 parts. This is 90 degrees. This is 180 degrees. This is what? 270. And this will be 360, right? Well, if I'm at about 65 degrees, that's going to probably put me right about here. Actually, I'm gonna actually move it a little bit lower. It's going to probably put me right about here. Just before what? Rinse. Why? Because rinse is here. What do we do before rinse? Okay, and you're like, well, why did I pick that specific spot? Okay, well, if we look at it, this 15, 12, 8, 4, what does that mean? But a little more detail. It's wash. Well, what I'm looking for is, remember, while it's filling, if I put the timer right there and start it on 15, that does not move until the machine fills up. So it'll actually wash with water for 15 minutes before it does what? Before it drains. And that's where this pump comes on. Okay? So if this is 4 minutes, if I took the gap, then 0 would be right about here. So the rinse would be, the drain and spin would be right about there somewhere. Just like the idea of how to take this information, what you see on the chart, and try to pick out where are you laterally on this dial. Was that, I don't even know if that's the correct way to say it, laterally on the dial, but I liked it. So do you all see that and how I figured out that question? We might do one or two more of these as a practice. And by the way, that timer is that machine. It's 100% that machine, because I went and got the service manual and found the timer picture on the diagram and took that from the service manual of that diagram. So it is that exact machine. It isn't like I just made something up. Okay? Number 8, identify which switch, and I forgot the letter T in that question, for each cam that is closed on increment 9. So when you went on increment 9 now, you would say 14B, 12T, but then what I really liked, did you forget the pizza's in the oven? I smell it. You're not burning it, are you? Oh, okay, it's just the heat of the oven then. Okay, so in other words, these are the cams, but those aren't the switches. The switches I was looking for, I think, were the numbers. But I did put the cams on my answer key, so let's go by cams for now. Oh, this is the wrong paper. I didn't make an answer key on this one. So which switches for each cam is closed? So we'd have to look at the cam 0B, for example, and then you'd have to go back to the diagram, and 0 bottom would be this one. That's 0, and that's the bottom. So it would be T2 to T6 or T3, but T2 to T6. Now, the other thing is when you're looking at this, let's go ahead and go back to switch 12. And we said that's T21 here, right? Switch 12 is T21. Now watch what I'm going to show you something here. I have to go to this picture here. T21 is here. So this cam is what cam? 12. All right, so if we go back to the chart again, just follow me for a second now. I got to go back and forth now. So that's cam number 12. That's cam number 4. Let's look at cam 0 for a second. Cam 0 is T2 and T6. So if I go back to this diagram here, there it is. T2 and T6. Wait a minute. Oh, but you see how 6 and 3 are mechanically connected internal? So remember, it said T3 or T6. It doesn't matter. When 2 closes, it's actually making contact to both those pins, isn't it? So this is cam 0. What is this one? 2. 4, 6, 8, 10. And what did we say this one was? 12, 14. That's important. So when we go to the chart, like we were doing here, and we said, oh, well, what cams or switches that are closed? We said 0, 4, bottom, 6, top. 4 bottom, 6 top. Well, I go 4 bottom, 6 top, 0, 2, 4 bottom would be what? Here and here or here and here? We go over here to 4, and it only has one position. That's T9. So T9 is here, so it's this one. And then 6 top would have to be this one, because if that's bottom, what does this got to be? Top. So this is 4 bottom, 6 top, 8 bottom, 8 top, 10 bottom, 10 top, 12 bottom, 12 top. This whole row is bottom. This whole row is top. This is middle. And we count here 0, 2, 4, 6, 8, 10, 12, 14. And the importance of that is when you go to the chart and you want to check a switch, and I say, well, I want to check 12 top. I can physically look at the timer and say 0, 2, 4, 6, 8, 10, 12, here, 19. and 12 top is here to 19 is up there. I can't move that diagram. But that is how you take and you say, well, if I want to check that switch in the timer, where do I put my meter on the timer to test it? And you'd have to go from here to here to here to match it all up. It is a little complicated, but remember, back then, that was the easiest way they could make it. And that's the way all timers were on all brand machines. Okay? So, what cycle and function is increment 9? Increment 9, the regular cycle, and the function is pump spin. Okay, regular cycle here, pump spin. All right. And the last question is highlight the active circuit in increment 9. So now we had to take all those. Did someone write all them down so that I can go to the other screen and not go back and forth? So that's 0 what? 0 bottom? 0 bottom, 4 bottom, 6 top, 8 bottom, 12 top, 4 bottom. 14 bottom, I mean. So if we go back to here, what were the switches that were closed? 0 bottom, so we're going to go here. What's the next one?
4 bottom.
4 bottom, we only have the 1. 6 top is here. 8 top is already closed. 12 top is already closed. 14 bottom here. So now what I wanted you to do is to highlight just the active circuit, only thing that is running right at this moment. And here is line 1, so power actually comes in here. A lot of people probably started at that one because they're used to starting at the top, but that's the neutral. Power's coming in. And notice on this machine, power goes through the overload in the motor. If this lid switch or that overload's bad, nothing in this washer will operate. Nothing. They all go through that component. Now, this circuit's closed for the motor, so I'm going to go ahead and just, I don't know if it's running or not. I'm going to go here, and then I go this way, and I'm going to go here, and go to my cold water valve. And this completes that circuit for the cold water valve, but I can't bring my motor, go through my motor, and then go through a water valve back to the motor. That's not a circuit. You can't put 2 loads in series like that. So let's fix it. Okay, I'll leave this red for the hot. Okay. So that's the hot. It's going to come through here. Going to come through here, and it goes here. And now I'm going to go to my water valve here. And I'm going to go to here. Let's assume the lid is closed and locked. And the pump goes like this. Now, if we go back to the chart just for a second, well, not that one. Let's go to the chart here. What did we say the machine's doing? The pump is running and it's spinning. The motor should be running too, right? In that case, what other part should be running? Well, I said the motor. What other motor? The timer motor. If the motor's running, the timer motor should be running too. Okay, so we go back to the diagram. Now, I didn't create my neutral because Jose wanted me to do neutral, so I'll change the color for neutral. Actually, it is line 1 coming to both of them here. And this is line 1 here. We have to go outside. So if we looked at the neutral will come in, it'll come here through the pressure switch, but the machine's empty right now. No, it's drawn that way, but the machine's empty, so the power is going to come in here, and it's going to go through our temperature selector switch, and we'd have to close one of them. And since we're in the rinse is almost always cold. They shut it off. Yeah, they disabled it. So we're going to go through here just to feed this. This is through our PCB. What did I call that in the other diagram? I gave it 3 letters. ATC, automatic temperature control. That's a temperature control. There's your thermistor checking your water temperature. So this is a board that's controlling the temperature of my water. Okay? If I didn't want to use the ATC, I could have went through this switch and fed the hot and fed the cold here without using the ATC. But that's how the neutral fed my water valve in here. We said the pump was also running. I brought line 1 to here. The neutral of the pump would go this way, and then I have to go through here, and the neutral of the pump is feeding back through here. So that's the neutral of my pump. And we have to complete the neutral for the timer motor, and I already got red on the other side of my timer motor, so I got line 1 and neutral on my timer motor. That's crazy, isn't it, all those lines?
Yeah.
You're only going to get good at this if you continue to practice it. And by me giving you these exercises, it's going to help you get it. It's going to take time. Eventually, you'll be like, oh, then I can retire. Any questions on that?
So when it's spinning, will you go to the motor?
Oh, yeah, I'm sorry, I didn't even highlight the motor. So we do need to come, let's go back to the red one. We got power here, right? But that switch is not closed and that switch is not closed, so I can't go through either one of them. So if I come through here, let's go ahead and do the neutral side of the high-speed winding. That'll be here, and that'll come in and go through here and then join up here with neutral, okay? Actually, I don't think it's connected there. I think it has to come through here and then join the neutral there. And then the start winding needs to be connected. I don't know if those switches are right. What was 6 and 8 in CAF? 8 bottom was closed? So, and then 6
top, 8 bottom, yeah.
6 top, 8 bottom. That's where my mistake is, because I think I did 8 top. So 6 top is closed and 8 bottom? Yes. Like that? Okay, that makes a little more sense. Let's see if I can complete that circuit. So if I went through here, look at this blue one right here at the bottom. So if I continue that blue circuit, it comes back through here, it goes through here, and then it feeds one side of the start winding. Now the red side is the other side, and I have to connect that back to the power, which comes here and goes to that one. Oh, that should have been red. I'm sorry. I thought I hit red. So this one comes out, goes through here, goes down, and connects that. That is the most important thing in the next thing we're going to talk about. Do you know that all 4 of these diagrams, if I put those motors side by side electrically, I could unplug that plug and put it on another motor, and it'll do the same thing to the next motor from one brand to the next. If we look here, this is all 4 of those motors from the diagrams that we've been practicing. We got the Whirlpool direct drive. We got the Frigidaire one we just did. We have the Maytag and the Admiral, or the Admiral and the Maytag. Let's pick out some of the similarities and explain a little something. Start winding. start winding, start winding, start winding. Tell me one thing by looking at them all. What is similar about the start winding in all of those motors?
The winding itself or
The winding itself. What? Well, what is different? I don't know how else to explain without giving the answer. That's what I'm trying to say. The start winding doesn't connect to the run winding. You see, like we got multiple speeds here, and they're connected together. You notice the start winding does never touch them. If you look at this start winding here, we got a high and low speed connects to a common terminal there. Start winding doesn't touch it. If you look at this start winding, we got two speeds on this motor. Start winding doesn't touch it. This is the only one that's single speed, but guess what? The start winding doesn't touch the run winding. We have to do that so we can reverse the motor. The motor can run one way for wash and the other way for spin. And that we have to do with two sets of timer switches. I have to put a timer switch on one side of the start winding and a timer switch on the other side to bring line one in this way or bring line one in that way. Hoping they'd reset that